Okay, so videoing faux pas. I intended to keep that video going while I was setting up the iPad, but it stopped and I didn't realize it until I finished an entire example. So let me walk through this with you. So going back to page 6, I'm working the example on page 7 and the steps are on page 6. So page 6 says, step 1, find the function values at the critical numbers. So first I need to find the critical numbers. Critical numbers are the places where the derivative is either 0 or undefined. This is never undefined. There's no x value I can plug in here that will cause me a problem. I can plug in any x values, right? So all I have to worry about for this one, and many of them, not all of them, but many of them, is when the derivative is 0. And then factoring, right? And I have faith that you guys can factor that. Finding the critical numbers. Critical numbers are the x values where the derivative is 0. Then I plug those in. Step 1 says find the function values at the critical numbers. So these are critical numbers. I find the f. I plug them into f. So I plugged the -1 into f here and I got 3. I plugged the +1 into f here and I got -1. Step 2 says find f of a and f of b. Well, a and b are the endpoints of the interval. So f of a I plugged in 0 and I got 1, right? F of b I plugged in 3 and I got 19. Okay. Step 3 says that if I compare all of these values, so this guy, anything from any function value from step 1 and the two function values from step 2, the largest of them is the absolute max and the smallest of them is the absolute min. I'm not going to do b yet. So if I look at the function values, 3, -1, 1, and 19, the absolute max is 19, and the absolute min is -1. The question just asks you to find the absolute max and min, so you're actually okay if you stop here. However, sometimes the questions on the AP exam are a bit ambiguous, so I always list where they exist as well. Sometimes they will ask where, sometimes they will ask what are they. We'll talk more about that later. So that's why I stated that the absolute max is 19 when x equals 3, and the absolute min is -1 when x equals 1. So if you look at the -1, the x value was 1, and the 19 happened when x was 3. So let's look at this graphically. I know I've got some points. Now this is just going to be a sketch, okay? I know what x to the third looks like. Now, keep in mind, I'm only looking at the interval from 0 to 3, so I actually didn't need to do that one because -1's not in the interval. So I know f of 0 is 1, over 0 up 1. I know f of 1 is -1, so there. And I know f of 3, so let's call this 1, -1, and then I'll put a 19 up here. F of 3 is 19. So my function looks something like this. So I want to emphasize again, because in the next, actually the rest of the chapter, this is the only section we're looking at a closed interval. We know in x to the third graph it's probably going to have another hump. I mean, it's not probably, it's definitely going to have another hump. It could be here or it could be there, right? Let's see, we know, well, I don't want to get into it. I don't want to waste time. But on this graph, I'm only looking at the interval from 0 to 3, so the absolute max is the highest point. The absolute max, the highest value that this function attains on this interval is 19, and the lowest value is -1. So it's as simple as that. Okay, so let's see if I can get through. Let's start a new piece of paper. Let's see if I can get through example B without making this ridiculously long, and it's got trigs, so who knows what's going to happen. Okay, so step 1. Critical numbers, derivative of sine, derivative of cosine, set it equal to 0. Sine and cosine are defined everywhere. There are no undefined values, so I don't need to worry about where the derivative is undefined. This is why I said to highlight that in that definition of critical numbers. So, when does cosine minus sine equal 0? Okay, well here's another way of thinking of it. Move the sine over to the other side. When does cosine equal sine? Hopefully you know the answer to that. When does cosine equal sine? And keep in mind, we're only looking from 0 to 60, or 0 to pi over 3. So the answer is, it happens when x equals pi over 4, or 45 degrees, because that's where you have that isosceles triangle, the 45, 45, 90, where the x and the y are the same, right? Cosine is x over r, sine is y over r in the unit circle, so we want to know where the x and the y are the same. So this is my only critical number. I only have one. critical number. Still in step one. Step one says find the critical numbers, then plug them into the function. So what is this function value? Sine of pi over 4, cosine of pi over 4. This is like having a half of a rad 2, right? 1/2. And this is another 1/2. So that's a whole rad 2. Or you could do it, think of it as this is 2 rad 2 over 2, however you want to think of it. I'm done with step one. Critical number, plug it into the function. Step two says find the function values of the endpoints. So I'm going to plug 0 in. Original function, not derivative. Sine of 0 is 0. Cosine of 0 is 1. And then pi over 3. So what is this going to be? This is going to be a little messy. We probably need a calculator. Hopefully my phone has the capability that I need for it. What is this? It's 60. Sine of 60 is 1/2. And rad 3 over 2. So we could estimate. I know this is bigger than 1. Well, I know it's 1.414. Maybe you don't. You use a calculator for that. 1 plus rad 3. No, I'm not going to try and estimate that. Let me do it on my calculator. So rad 3. Oh boy, sorry, dropping my phone now. Rad 3 over 2 plus 1/2, 1.366. Rounding to 3 decimal places, right? AP exam, rounding or truncating. So now I'm going to compare these values. So I've got I only have 3 function values. Last one I had 4 because I had 2 critical numbers. So the absolute max is, which one's the largest? Looks like 1.414, right? So rad 2, let's give an exact answer. And the absolute min, comparing these 3 y values that I got, is 1. And again, covering my bases, I'm going to say, where did that happen? That happened at x equals pi over 4. And where did that happen? That happened at x equals 0. And I'm done. I could draw a graph for that one, but I'm going to keep the video short. All right, fun stuff.